triggers, I talked about those to a certain extent already, but I'll just reiterate a couple of points. When we looked at version 9, we had what were our standard triggers where you had the UI for editing them, and then we had things called the extended triggers, which we'd potentially use on DSPs for binding some of the events, or if you had an OCX control and imported that, you'd find that it would create triggers to bind to the OCX controls. So the concept of having the keyword trigger to define an event has actually been there for a little while in Uniface 9. What we've now done is just, again, standardize the functionality, have a single container, and now we define all triggers in a consistent manner. So yeah, we used to have what were the standard extended triggers. We now say just to think of them in terms of system triggers and user triggers, or system events, so triggers that are fired as a result of something on the system, and then user actions, so the result of a user doing something, so the user doing a detail, or occurrence gets focus, or next occurrence, or things like that. I guess you could draw the parallel of the old structure editor type events or triggers. So the structure editor ones were the ones you would see in the trigger editor with the angle brackets around, because those were the interactive or user triggers. So we just think in that sort of terminology now, system events and user events. As we see on screen, exec is a standard operation now for the reasons I mentioned before. Other things that have changed, something like the application execute trigger now is just defined as a trigger called app start. And I mentioned already that we've renamed a number of the triggers. That was to make things more consistent and more just understandable, particularly if someone new to Uniface. You didn't have to try and understand what this trigger means and the context of the trigger, because hopefully we've got the naming to be much more intuitive and more obvious. In terms of triggers, things to remember about inheritance and overriding things are, if you define a trigger locally with the same name as a trigger that's in a super type or that is inherited from somewhere along the chain, then your local definition will override it. Now, a piece of behavior that is now consistent, which unfortunately wasn't always 100% consistent, so there was a little bit of magic in there at times, was what's considered to be an empty trigger. And what I mean by that is, sometimes in the past, if we had an empty trigger, where empty was a trigger that you hadn't put any code in, or you only put comments in, or it potentially had include procs that evaluated to just comments or blank, that trigger would be considered as empty, and it would potentially then be inherited from a super type. The behavior was inconsistent, it was magic, you couldn't predict what was going to happen. These days we've made it very clear cut and consistent. If you define a trigger locally, and that's whether the trigger has its implicit behavior or scripted behavior, if you defined it locally, whether it's blank or has code, your local variation will override and break the inheritance. To restore that inheritance, you just need to delete that trigger if you want to go back to the original code. I keep saying triggers because they're slide triggers, but that naturally applies to operations and local procs as well. And I mentioned another concept there that you might not have been aware of, but I said some triggers potentially had implicit behavior, whether there was script or not. An example of that was the exec trigger, which was really an operation. By definition, when you have a new component in Uniface, the exec trigger was always empty. However, although it looked empty, there was always implicit behavior, which was the edit modal or edit non-modal, depending on the component type. If that implicit behavior was there, then by definition, whenever you ran a Uniface component, you wouldn't see it unless you wrote the edit statement in there. So again, we've made things consistent, because although you could override that and do things, the behavior of when it got overridden and didn't get overridden was inconsistent. We have now made it absolutely consistent. If you've got a local variation, that is the one that takes precedence. It's a clear-cut rule. The other thing to help, which I mentioned before, and we'll see again in a few slides, is even if you've still got any confusion as to what's being included or not being included, at compile time everything gets resolved and shown in the CMI on the right hand side, so you know exactly what your component's composed of. And that's particularly important if you have a bug in your code or strange functionality. At least you can immediately navigate to the code that's being executed and not accidentally start trying to look for an issue in code that isn't actually being executed. Something else that's changed from a UI point of view and a definition point of view is relationships. Naturally, you can still define relationships in Uniface as in any data modeling. The difference now is it's more driven by the many entities. In the past, we would pick the one entity and then pick the many entity and pick the foreign keys that way. From a usability point of view and also a data consistency point of view, because again there was some magic in Uniface before which could lead to inconsistencies if you changed foreign keys on the many entity. We've eliminated that risk now. When you're editing your main development object or your development object, so your entity, you go to the Define Relationships worksheet. So you can see we've got this extra worksheet for defining relationships. You'll see your many entity, or it will be treated as the many entity, and you'll see it on the right hand side. It says many entities. The reason that's plural is if you've defined any entity subtypes against this entity, then they'll also be listed, which means you can have unique relationships between the subtypes and the supertypes if you want. They'll all be listed, and then all you do is drag and drop, pick the one entities, drag them across. It will show the relationship as the one-to-many relationship, and then you just pick the foreign key. The UI is different to what we had before. It's a bit more drag and drop and point and click, and a little bit more visual than it was before. In the past we just had the repeating group or the repeating entity. So this is just a bit different, a bit more visual, but it's the new way of defining relationships. Things are more consistent. We have our main development object, so the entity editor. So when you're on your entity, you've got the defined structure, so you're adding the fields, you've got to define keys and indexes. Speaks for itself what that worksheet does. Define relationships is the next worksheet for defining the relationships, and then write script if you're going to add your inheritable code. One of the next changes, and one of the most significant changes for most of us, is the defined frames worksheets for forms and reports. So this is what was our graphical form painter. It now follows the version 10 paradigm fully. It now follows the same single UI flat structure, so it's much easier. As you've seen, we have the resource browser, the structure of the component, and then we have the canvas itself, and as I mentioned before, the properties. What I'll do, rather than just talk about this, I'll just show you creating a component and just a couple of little tricks. So if I start Uniface 10, just open my project. So here's the new project I created before. I'll just create a new modal form, or non-modal, makes no difference really in this case. I'll give it a name, test1, which I've already used, test2. And open it and we can see we're onto the component. So I can now define the structure. I've got my templates here. What I'll do is I'll just paint an entity. So I'll go for the address entity. In 9, the form painter was a separate window. Here it's not, so it's not immediately obvious what size the component is. For example, if I shrink down the IDE, it's not necessarily clear what size the component is going to be when I run it. There is actually a visual cue on the screen though, and I don't know if it's coming across on the Skype session, but there's this dotted blue line which is showing you the actual size of the component. So if I want to change the size of the component or even the position, you can see it's just properties. I don't have to go to window properties on a menu or anything like that. I can just change the sizes here. So I could edit those and change the properties. So height and width was on the entity there. So height and width here. So if I change like width to 40, we can see the dotted blue line. So that is the actual size the component will be rendered. Before I was here, and you can see they're grayed out. They're not editable because the way I change those is by just physically changing the entity or moving it. So again, properties window is context sensitive. So that's how we know the size of the component we're working on. Now, the normal way of painting fields here is to get a field, drag it and drop it, pick the other field and just paint it like that. What we don't have that we used to have in version 9 is load fields. That has not been implemented yet. It is currently being developed. There are working prototypes. It will come along in a patch soon enough, but I don't have a date for that. If you do want to have load fields type functionality, there is a simple trick you can do, and I'll show you two things. The first is you just basically convert your component to a service. Now, I don't have to look for a file menu or go up here and say convert to service or anything. What I can just do is go to the property of the form, so give the form focus. Under behavior, component type is form. I can just go to the drop down list. I'll just temporarily pick service. And on here I am able to do a multi-select against the fields and drag and drop them. Whether I'm doing a control or a shift, I can drag all of those in. They're added, and then back at the component level, I can just go back to the behavior, go for 0, and I've got a rudimentary load fields. It doesn't have the labels, but then another quick trick there is for the labels. Go to my templates. Here's my labels under data display. Normally I could just paint a label and then I'd have to rename it to associate it, but quick trick you can do here is with the label, just drag it across the field and it will naturally be associated to that field. So it's a nice little trick. So it's not a fast form load fields in a traditional sense, and as I say, there will be new functionality coming to just do this natively, but in the meantime there is that little trick of quickly convert it to a service. So go to component level, behavior, component type, change it to a service, and then do the multi-select, drag and drop onto the entity, and then just come back and change it back into a form. Really easy to do, and it is a simple workaround. The other thing just demonstrating there is, again, when we used to think about going to the menu, we don't need to. Things are just properties of a component, so if there's something you think that needs to be done about a component, it's all in the properties window. The compiled modules inspector is something new to the IDE, and this is the view on what's actually compiled into the component. As I mentioned previously, in version 9, to a certain extent the inheritance and the overlaying and all of those things happened at build time, but now, to ensure consistency and to make sure we know exactly what's going on, it occurs at compile time, which is quite a big paradigm shift for Uniface. However, the benefits it brings are simply great. So what we see here is the compiled modules inspector, and it shows me exactly what's been compiled into the object. And like all of Uniface, different icons give you an indication of the type of thing that's been compiled in and where it's come from, and through practice you'll learn what the different icons are. Let me just show you this in practice, because it's better to see it than just try and talk about it. If I go into Uniface, and I go to the component, here I've got my countries form. I've got no local script defined. And at the moment, on this side, the CMI shows no modules available. And this is a key thing to remember about the CMI. It is the compiled modules inspector. So I haven't compiled this component yet, therefore it doesn't know what's in there. If I now compile the component, it's done, and we can see everything that's been compiled into the component. I can see with this icon that it's being inherited, and it's obvious in this case because there is no script in these triggers. So here's the entity occurrence triggers. We can see that this must be inherited. If I double click on one of these, so for example operation exec, it takes me to the actual definition, and what we can see is mod FRM1. This is one of my modeled components, and I'm now going to repeat myself. Modeled components are inherited from, templates are copied. So in this case it's one of my modeled objects, and we can see this is where the inheritance comes from, and we can see all of the operations there. Just to show breaking the inheritance, if I was going to make my own special variation of this exec operation, I'd define it locally. You can see the icon here has got that little arrow showing the inheritance. If I now compile this again, it's changed to a cross. We can see that the inheritance is broken and that this is a local variation. Here's two differences about Uniface 9. This code is exactly the same at the moment as what was defined in the parent. If that was Uniface 9, Uniface 9 would implicitly be doing inheritance still. Again, this is where some of the magic came in, because sometimes it was, sometimes it wasn't, and it wasn't immediately obvious. In this case, I have code defined locally, so I know this is the one that is being compiled in. If I make this an empty operation and compile, we can still see that it is a local variation. In Uniface 9, the behavior was consistent, but it wasn't necessarily obvious what it was doing. If I remove this operation, we can see the arrow has changed again because I've now reinstantiated the inheritance, so it's inheriting from the modeled component again. So this is quite nice, and I did say this is a big change when we look at the containers, because in previous versions of Uniface you saw all of the code that you believed was being compiled in, and sometimes it wasn't. Now what we see in the component is the actual variations we've done and what's changed. And if we want to interact with the inherited stuff and know exactly what's inherited in our components, then we just go to the CMI, double click, and it navigates us straight to the thing. Again, here you can see it's gone to the exec because that's what I double clicked on. If I go to quit, again navigate straight to the quit trigger. It is a change, but it is a significant improvement. You're going to get used to it very quickly, and you're going to love it, especially when you're debugging, because you're going to know that you are always touching the code in question. So that's the CMI. The next productivity enhancement that's been added, and this is completely new to Uniface, is the snippet libraries. Now the snippet libraries are another type of template, and what they are, as the name says, code snippets. It can be effectively any text, whether that's HTML, proc script, or just plain text, and it's just whatever you want it to be. So traditionally I've seen a number of developers who have their toolbox of useful piece of code, useful routines or constructs, which they'll have in Notepad or whatever, and they will just copy and paste to save them time. To make it easier and a better experience and something that can be shared within Uniface, we now give you the facility to put those snippets into Uniface, and we also include a number of them. And again, they are pretty straightforward. I go into my component and you can see I've gone into write script. They are templates, they are labeled snippets here. It's just a class of templates copied, models inherited. When I copy a snippet, so for example, I'm in the script trigger here, let's say I wanted to add the quit trigger and I don't want to type trigger quit myself, then I can just go for this example one, right click, insert into main editor, and there's my quit trigger. What you'll find is we have changed trigger names. You might not remember all of them directly. Well, there's a list of snippets here that will help you. An immediate thought you might have is, but I don't know which triggers should go onto a particular type of component. In this example, my component is empty, but the reality is when you're building components, go to my project or a project, what you can see is there are both modeled components and components templates for the different types. So I've got forms, reports, services, server pages, etc. Those will already be templates that contain the correct triggers you expect. So although it might have sounded scary at first when I said we've removed all of the triggers and it's all in one container, and then you've just seen a blank screen here and you're thinking, I can't remember what triggers apply, it's fine. We have the templates for each type of component, so there's nothing to concern yourselves with there. It's still very easy. As I say, snippets can be anything. We have a whole load of standard snippets. You can see these are snippets specialized for forms. If I click here, we can see we've got all sorts of other types of snippets we ship by default. So here's our snippets for reports, services, session services, etc. I've got some HTML snippets. So for example, we might have snippets for just creating a table or div sections or whatever it might be. And also, you're going to do this in your exercises. You're going to create your own snippet library. So where you've got your toolbox of bits of code, just put them into a snippet library and you can keep that to yourselves. You can share it with the community or your teams, basically enforce standards and ways of working. Again, the thing to remember with snippets is these are just helpers. They are templates which are copied, not inherited. In essence, modeled components are what we previously called component templates. To repeat my mantra, modeled is inherited, templates are copied. So to be consistent, we renamed what were our component templates to be modeled components because inheritance happens. We introduced some new properties to support the consistency but actually add additional functionality. So things such as, are these entities generic? Is it bound to something, and what is it bound to? Best parts about this are the bound to, because if you think back to version 9 component template, when you created a new component and based it on the template, you had a binding wizard that came up, and that was a one-time process. Once that component was created and bound, you couldn't then change any of the binding information. So that was sometimes a challenge, because if you made a small mistake or something like that, you'd find yourself deleting a component and recreating it from scratch. With these properties and the properties window, you can just change them. There isn't a binding wizard. All you do now is to rename the field or rename the property and the binding will take place. I mean, if I just show you where that is, if I go into version 10, and here I have a component where we can see inherits is set to true, so this is based on a modeled component. It's based on mod FRM1, so it was modeled from that. It in itself is not a modeled component because it's inheriting from this modeled component. But what we can see is when we look at something like the entity country that I have on here, there's the name that I've set it to, so it's the country entity. But when we go down to the configuration, we can see it inherits. It inherits from this entity and it's bound to acmeGen. So I had an entity on that template called acmeGen, and then when I created this component by dragging the modeled object into my project, renamed it to country, I then just came in and did the binding by renaming this to the entity I wanted to bind to. If I want to bind to another entity later, or with the fields as well, I want to change the binding there, I can just change the name. So that's quite neat. Also, if I have a component that is a final component already, I do have the possibility to make it into a modeled component, again, just by changing its property of whether it's a modeled object or not. The key thing you'll find as a main benefit here is how simple it is to bind things simply by renaming fields, and then how easy it is to change that binding. Something else to point out when we talk about the inheritance, and I've sort of implicitly said it before, but maybe it wasn't completely obvious, and that's when we think about the overriding. So when I was talking about the CMI and what's actually inherited and what's overridden, and here's a scenario to think about. When you look at the inheritance and overriding in version 9, it wasn't actually at, let's say, module or code level. So if I had code in my quit trigger, it was actually that container that was being overridden, not necessarily the code inside. To make that clearer, if we think about the operations container in version 9 that contained all of my operations, or the local proc modules that contained all of my local procs, by just modifying one of those operations, I was effectively overriding that whole container. So I then made everything a local variation. Now, there are exceptions to that rule, and that's where I talk about the magic that was inconsistent and unclear to everybody. Now, as you can see, it's crystal clear. If I override a single operation, it's just that that's being overridden. Or if I override a single trigger, it's just that trigger. So overriding an inheritance is down to the actual trigger, entry or operation level. It's no longer across the whole container. So it's a small change or subtle change, but it clarifies things. Something else to consider about containers in this area is if you're doing a modernization project and you're converting components from, say, forms to web pages, if you were doing that in version 9, when you convert the component from a form to a DSP or USP, Uniface 9 would only present the triggers that were actually applicable to that component. So what you could find is you'd have your logic embedded in structure editor type triggers, which naturally aren't directly available on a USP or DSP. The challenge there is, if you've already converted a component, you can't see that code anymore, so you'd have to convert it back and then convert it forwards, or copy the code, or duplicate the component. Basically, it was hard work. Now, with everything being in the same container, when you convert the component, everything is still in the same container. You can see all of your code. You can then move it to the appropriate places. You don't need to worry about those extra triggers being there in the meantime, because Uniface will only compile in the triggers that are appropriate to the component type. So it basically makes modernization easier because you've still got access to all of the code immediately, and then you can move and clean up as appropriate. And you don't have to start duplicating components or exporting things. It's just nice and easy. The other type of modeled objects we have are modeled properties, which were previously your field interface, field layout and field syntax things. Those still exist, and they're all under more editors, and you've got modeled entity interface, field syntax and field layout, and these all exist in the default library lib, and that's just hard coded. It's an untyped library because it contains multiple different types, and that's just how you define these modeled objects. We'll now talk about component variables, global constants, so hash defines, and what's changed in version 10. Now, when we look at version 9, we had a dialog for creating the component variables, and we had global constants defined in a library, again using a dialog. In version 10, it's slightly different. If we take a look at component variables, You can define your component variables, and they have container level scope. In the declarations section of your container, a variables block, type, and a name. And that's my component variable created. Really easy. I didn't have to go to a separate dialog box, and I have complete visibility straight away of what I need. If I'm doing code analysis, it's there. Again, I'm not having to look at different repository tables. I'm not having to go to different dialogs. It's nice and easy. Likewise, if I want to do component level constants, I mean, we used to have the defined trigger. Again, we just put it into our declarations now. So hash define whatever you want. And so that's created my component level constant. It's really easy. There is one difference about the constants here. Before, in version 9, they had trigger level scope because each trigger was its own container. Here it has container level scope. As you can imagine, because the container has all of the triggers in it, the scope of this define is therefore spanning all of the triggers as well. If you do want to reduce the scope, then we have a hash start define and a hash end define that you can put around the area where you want to refine the scope or limit the scope, so you can still achieve what you had before. In terms of making global constants, then what you do is create an exclude script called def param, so it says on the slide. And on that, in the include script library, that will then become your global constants where those libraries are used. Just like previous versions, if you want that to be global across the entire application, then you can just put it into system library, which by default is used by everything. We're now going to talk about user-defined worksheets and menus. This functionality allows you to extend Uniface 10 IDE in a much better way than you could with version 9. In version 9 we had the additional menu, but this was quite limited in its functionality. Another artifact of the version 9 additional menu was that it didn't actually run in a sandboxed environment, so you effectively had access to the whole of the Uniface memory space and objects that were running. This clearly isn't good from a security perspective. The enhancement to the Uniface 10 worksheets and menus is that they do run in a sandboxed environment, and if you actually want to interact with the IDE functionality and interrogate data, then there's a defined API we've added which does things in a controlled, secure manner. The user-defined menus are both global and context sensitive, so the global items you add will appear in the hamburger menu or the main menu item of Uniface, whilst the context-sensitive items will be added to the Actions menu in Uniface. Worksheets are a new function, and that follows the paradigm of Uniface 10, where each main development object's editor has a number of worksheets for defining and manipulating those objects. Technically, you can add any number of additional worksheets. These worksheets open up the capability to extend the functionality of the IDE with pretty much anything you can imagine. Building the plugins is actually quite simple. There's a logical that you add to the assignment file which specifies the name of your plugin components, and these are just normal Uniface forms, and there's a defined API with a set of mandatory and optional operations. We'll talk about those shortly. What I'll do is I'll show you some of these worksheets in operation, and then we'll look at the API. Okay, so here we are in my Uniface 10 environment. Here we're just looking at a DSP, and as you can see, well, I've been experimenting a lot and I've got a number of additional worksheets here. Now the standard worksheets on a DSP are the defined structure, so painting my entities and fields, layout, which is defining my HTML layout, and then my script. Now, an interesting thing is with the layout editor, we have a text-based HTML editor, and we don't actually have a WYSIWYG editor or a previewer. So, what we've done in one of our worksheets here for my experiment, was just created a preview worksheet, and so as you can see it renders the HTML as it would appear on a website. This isn't picking up the CSS at this stage, but again that would be very easy. Building this component was actually very simple. It is just using the Uniface HTML widget, and I'm loading the HTML content that was written in design layout. I'm just loading that straight into the widget and it's rendering it. Another experiment I've tried is a listings tab. We don't have a view listing menu item, however I'd say this took me a grand total of 45 seconds to build, and again I'm just doing a file load into a multi-line text box to show my component listings. Again, this is context aware because part of the API is that the context of where I am at the moment gets passed in, so I know which component I'm looking at, so it's easy to pick the right listings file. A few other experiments, some statistics about the page. Again, as I say, you can be building anything you can think of. One of my colleagues built this version, which does a bit of cross-reference visualization. Again, here we're just using the HTML widget and some D3 controls to visualize what objects call whichever object. So we can see the exec operation here, it calls instance parent, forgot.detail calls main.setPage, and yeah, you can get a picture. If I just take a look at another component here, let's go to that statistics one again. Again, we can see that this is much more extensive, and you can start to imagine that you can build all sorts of tooling around this to extend the capabilities of Uniface and plug in extra functionality, and things like this would be really useful for impact analysis, for example. Something else I've plugged in is the performance tool functionality that you may have seen. It's available on GitHub. So here for this component there have been a number of test runs run, and I can just directly from the component I'm interacting with see the logs that are available from the test runs and see the different performance results. And this is just literally loading the components in straight out of the performance analysis tool with the API wrapped around them so that they can actually be loaded up. Another experiment here is just again some more visualization of information, and again as I say, the sky's the limit. Whatever you can imagine you can build. Now, in your exercises you will be doing later, you will be building a simple extension, and I'll just show you what that's going to do. Here we can see that I'm on my modeled component at this stage, and I've got this statistics tab, and that's something you're going to be building. And again, this just shows how many entities are painted, how many fields, and how many lines of code. Again, the sky's your limit with your imagination, and what we'll see is the API for actually plugging these things in. Okay, so the Worksheet plugins, basically there's 3 mandatory operations. Get version, returns the version number of the API that you're actually using. At the moment we're on version 1, but for future compatibility we need to make sure that there's a way of identifying which version of the API is in use. So this is how we can make the code future-proof and compatible as things move forward and change. Get worksheet options, again it's called by Uniface to find out options about the worksheet, and at this stage it's just a struct that contains the title and a tooltip. So again, if I go back, you'll see in your exercise you set the struct, and you'll have the title, in this case statistics, and when I hover over we say show component statistics, so that's the tooltip you'll be setting. Then finally there's WS Activate, and this is the operation that's called when you click on the tab for the first time and it loads the worksheet. Then we have a number of optional operations, and they sort of speak for themselves. So WS Get Visible is when the tab is given focus and it becomes visible. So it might be that you want to do some sort of refresh functionality or something else. Gets Invisible is when the tab's closed. Yeah, potentially you might unload stuff, or again it depends on what the functionality of your component is. Object renamed, if for example I'm in my worksheet, if I'm on the define frame section for example, and I come in and I rename the component, then we want that context to be passed through, and it will be, and Uniface will call Let me go back to the slide. It will call the object renamed operation, and therefore allow you to pick up that change and again act appropriately if you've got to change something that your worksheet does. And then WS refresh is when there's a refresh issue to the current editor, then it allows your tab to know that things have been refreshed. And again, if you've got to update information on your component or your worksheet, then you have the option to do so. So it's a pretty simple API, and you will experiment with this in the exercises that follow. As I say, the sky's your limit. Menus follow the same paradigm. We have a logical section where you specify the Uniface components that specifies the menu items. And again, these can be both at the global layer, or they can be at an individual component layer where it is then context sensitive. Again, I'll show you an example of this. If I go in to this component at the global level, so in the Uniface hamburger menu up here, we can see I've added a launch profiler, which launches the profiler tool externally. This doesn't have any context passed to it as such, so wouldn't necessarily do anything. If I just come out of that. At the other layer, where it's context sensitive, so I'm currently on my S-profile data component, I can go in and you can see here I've got activate profiler. In this case, context sensitive information gets passed in. It could then be that I've done certain things on this tool, identified a problem, and when I come out, I'm now going to use the API to say to Uniface, I found an issue, navigate to a certain place on a certain object. So if I come out, we can see that it said, well, I found an issue in my tool on this create log operation on the S-profile data component, and so it automatically navigates to it for me. Again, it could be that it's a different component, so I could be, let's say, doing something on this component, and as I do my, sorry, it needs to be on a component, that was a project. It could be that on the tab quick view that I go through my tool, I do my analysis, I find something, and then when I quit, again it navigates to the problem area. In this case I've just hard coded it, but just for demonstration purposes. So defining the menus, it follows a very similar pattern to what you would have done or what you've seen so far with the worksheets. And then basically it's an API where we have some mandatory operations, and then there's some callback operations. So these mandatory operations, get version, again same as what I've said with a worksheet, get global menu options, so that's the hamburger menu or the IDE menu, and get editor menu options is the context sensitive action menu. And then these callback operations are the operations that are called when something is clicked. And again, you will go through this in the exercise and it will just become abundantly clear. Before we do those exercises, I'll just talk about two more important changes to Uniface 10. The first is our upgrade of the ICU library. So this is what we use to deliver the language support, or the NLS support, and it basically deals with the locales and time zones for each region. We have updated this, and what that means is we've naturally inherited any of the changes in international standards for date formats. For example, a country such as France has changed its short date format. Now, in practice, from a pure data point of view, this has no impact on the application as such. However, when we talk about formats and the visual interaction of data, then there will be a potential visual change. Again, for your application and for a human, that doesn't really cause any real issue. However, if something, for example, has changed format and you have regression tests where you're looking at a value expecting to see a particular set of characters on screen, then there is a chance your regression test will fail if the formats have changed. So this is one area just to check the locales, see if there's any changes, and if you think that your regression tests might be impacted, just keep an eye out for it and understand this is what the change is. It's not that there's a bug in your product or anything's broken, it's just that the standards on the locales have changed. The next important change is the introduction of TLS. We've introduced TLS to Uniface to secure data communication. So in essence, anything that goes over the wire or any sort of network communication. Now I've said over the wire, I mean it will also encrypt data on a local loopback connection, and because technically that can be sniffed as well. So anything that's considered network communication can now be encrypted. It's native to Uniface, it's simple implementation, and again we're using industry standards, so we're utilizing the Open SSL library to achieve this functionality. There are two ways of configuring it. There's pre-shared key authentication and certificate-based authentication, where certificate-based is using a public and private key pair. Now, there's pros and cons to these, and we'll just talk about those on the next slides. So pre-shared key, it's simple to implement, and pre-shared by definition means you have a known key that is shared with both the client and the server, or both ends of the communication. That pre-shared key just is basically a password, so a string of characters. And as you can imagine, there is a potential risk there, because if that key or password gets leaked or compromised, then by definition your encryption is no longer safe. It is quick and easy to implement, and we support 4 of the standard ciphers. 2 of them are disabled by default, and when things are disabled, again this is driven more by the community, it's going to be because these ciphers are inherently insecure, or they've been hacked recently or underperform, but are basically no longer seen as secure enough. AES, as you can see, AES128 and AES256 are extremely secure. Yeah, the next type of encryption is certificate-based authentication, and this is where we're using like RSA key pairs. So we have a public key and a private key, and the private key is basically held secure by the sender of the information. So the sender will encrypt their information with a private key, and then the recipient will decrypt with the public key. I discussed the advantages of this in one of my Uniface blog posts on uniface.info, and there's also a YouTube video available where we go into this in much more detail. So rather than me talk about it in depth here, I suggest that you visit those resources. That brings us to the end of the course. There was a couple of exercises to explore the worksheet plugins and menu plugins. If there's any questions, feel free to ask. Thank you for attending today.